In this warm-up, you are going to circle or select all of the numbers that are multiples of the given number. So we're looking for multiples of 2. 2, 16, 24, and 4 are all multiples of 2. Here, looking for multiples of 10. 5 is not a multiple of 10, but 10, 150, and 120 are. Go through and complete 2 through 6 in your composition book. So what seems to be her problem? She's trying to get 1 hot dog for every bun, but they come in different amounts. The hot dogs came in packs of 10, and the buns came in packs of 8. So she's going back and forth, selecting more packs of each to try and figure out how many hot dogs and how many packs of buns she would need to purchase for each bun to get a hot dog. Here we're going to record some notes from the video. We know the hot dogs come in packs of 8. And we know the hot dogs came in packs of 10. And the buns came in packs of 8. So the question that we're trying to answer is how many packs of hot dogs and how many packs of buns will she need for each hot dog to have 1 bun? How much will she need for each of them to get paired up with a bun? Or you can think of it as how many will she need to have an equal number of hot dogs and buns. And now we're going to work to answer that question. If we were to list out how many we would get from buying the hot dogs, we would have 10 from the first pack, 20 if we bought 2 packs, 30 in 3 packs, 40 for 4 packs, 50 for 5, and so on. We're listing out these multiples. For the buns, we would count up by 8s. 8 buns, 16 buns, 24, 32, 40, 48, 56, 64, 72, and so on. So if we want an equal amount of buns and hot dogs, I see 40 shows up in both lists. That means that they need to buy 4 packs of hot dogs, because that would be 4 times 10 is 40, and 1, 2, 3, 4, 5 packs of buns. For number 3, what is the least common multiple of 3 and 5? We are going to list out the multiples of 3 and 5. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and then we're also going to list out the multiples of 5. 5, 10, 15, 20, 25, 30, 35, 40, and we're looking for what's called a common multiples, those things that they have in common. I see a 15 in both lists, and I see 30 in both lists. But it says what is the least common, meaning the smallest one that they have in common. And the smallest number that they have in both lists is 15. So we're going to write LCM for least common multiple, and the least common multiple is 15. Now let's do the same for 4 and 8. Writing out multiples of 4. 4, 8, 12, 16, 20, 24, 28, 32. Now we will list out our multiples of 8. Maybe. Okay. The pen's not working. 8. 8, 16, 24, 32, 40. And so you can see there are many common multiples. But the least common multiple is 8. The lowest one they have in common is 8. So the LCM is 8. What is the side length of the smallest square you can create with rectangle tiles that each measure a 6 by 10? So think back to that original lesson where we were working with the digital tiles. And this time we're using tiles that are 6 by 10. So we are going to list out our multiples of 6. And our multiples of 10. And you can see here that our common multiple is 30. So LCM equals 30, which in the context of this question would mean that our square is 30 units by 30 units. It's going to have 1, 2, 3, 4, 5 tiles across the 5 6 tiles, and 1, 2, 3 of the 10-sided piece. Consider the numbers 11 and 12. What is the least common multiple of 11 and 12? So for 11 we have 11, 22, 33, 44, 55, 66, 77, 88, 99, 110, and 121, 132, 143, and for 12s we've got 12, 24, 36, 48, 60, 72, 84, 96, 108, 120, 132, and 144. So these have a least common multiple of 132. Now it asks us to write the prime factorization of 11 and 12. Well, 11 is just 11. 12 can be broken down into 6 times 2, and then 6 can be broken down into 3 times 2. What is the relationship between 11 and 12 and their least common multiple? Well, 11 times 12 would be 2, 2, 1, and 1, for a total of 132. The least common multiple of 11 and 12 is just the product of 11 and 12. So our prime factorization, if we multiply 3 by 2, that's 6, times 2 is 12, times 11 would give us 132. So it's their prime factors multiplied together. You can see here, 2 times 2 times 3 would give us that 12, and then the 11 from 11 give us their least common multiple. In a previous problem, we saw that the least common multiple of 6 and 10 was 30. What do you notice about their prime factors? I see the 3 here, and the 5 here, but there's only 1, 2 in that 30. That is because this is a common factor, so we only need one of them. So you can see here the prime factors of 11, the prime factors of 12, prime factors of 10, and 6. But this 2 is in both 6 and 10, so we only need to write it down one time. We are now going to roll 2 6-sided dice twice. So we're going to do it twice and add them up and then do it again. If you get the same sum on the second roll, then roll again until you get a different sum. So we're going to roll 4 times total, adding the first 2 and the second 2 to get 2 different sums. All right, so we are rolling a 6-sided dice. We got 2 and 5. Their sum is 7. So write that down in A. And now we're going to roll again. 1 and 5. That sum is 6. Now we are finding the least common multiple of the 2 numbers that we listed in part A. We're listing out multiples of 7. Oh, I skipped 21. 21, 28, 35, 42, 49, 56, 63, And now let's do the multiples of 6. And we'll find the ones they have in common. Oops. So the least common multiple is 42, which 7 times 6 is 42. All right, so I have that Venn diagram here, factors of 6 and factors of 10. And you can see that they are going to share some values. So we have 2 is a shared, 3 is just a factor of 6, and 5 is a factor of 10. Well, 3 times 2 is 6, 6 times 5 is 30. So that's a fast way to get to the least common multiple. Here I have factors of 8 include 2, 2, and 2. Factors of 12 is 3, 2, and 2. So for the prime factorization of 8, that is 2 times 2 times 2. And the prime factorization of 12 is 2 times 2 times 3. So the least common multiple is going to be 2 2's, because that's what they share, 1 3 from the 12, and 1 extra 2 from the 8. 2 times 2 is 4, 3 times 2 is 6, 4 times 6 is 24. So the least common multiple is 24. The greatest common factor would be these ones that they share. 2 times 2 is 4, so the GCF is 4. Remember, common factors are factors that they share, have in common, and they share 2 2's, which gives us a greatest common factor of 4. Each pack of hot dogs has 10 hot dogs, and each pack of hot dog buns has 8 hot dog buns. A shopper wants to buy an equal number of hot dogs and hot dog buns. What is the least number of packs of hot dogs and the least number of packs of hot dog buns he must buy? How many hot dogs and how many buns will he have? And explain. We already solved this problem earlier in the lesson. We know that they need 40 of each, so they will have 40 hot dogs. And 40 buns. That answers this question. We also need to state how many packs they need. To get 40 hot dogs, that would be 4 packs. And to get 40 using 8s, that would take 5 times 8. And we need to explain. 4 times 10 equals 40. And 8 times 5 packs of 8 is 40. The lunchroom, or slide 15, the lunchroom staff needs to buy an equal number of hot dogs and hot dog buns to feed 60 students. Is it possible to buy packs of hot dogs and packs of hot dog buns to have exactly 60 hot dogs and 60 hot dog buns? Explain. Well, our hot dogs come in tens, so 10, 20, 30, 40, 50, 60. So we can get 60 hot dogs. Our buns come in packs of 8. 8, 16, 24, 32, 40, 48, 50, 6, 64, but not 60. So is it possible to get exactly 60 of each? No. 6 times 10 equals 60. But 60 is not a multiple of 8. We would get 56 or 64. So we could have some hot dogs without buns, or we can have a few extra leftover buns, but we will not be able to get exactly 60 of both. Each pack of hot dogs costs $3.50 and each pack of hot dog buns costs $2. The lunchroom staff spends $48 when they buy an equal number of hot dogs and hot dog buns. How many packs of hot dogs and how many packs of hot dog buns do they buy? Well, let's start with what we know. We know that they could buy 4 packs of hot dogs. And you said that the hot dogs cost $3.50. And they also buy 5 packs of buns, and the buns cost $2. 5 times 2 is 10. 4 times $3.50 is 14. So that would give us a total of $24 for 40 hot dogs. But they spent 48. Four plus 4 is 8. 2 plus 2 is 4. So if they buy 2 sets of this amount, that would give them the correct dollar value. So that means instead of 4 packs of hot dogs, they would need to purchase 8 because they're doing this twice. So 8 packs of the hot dogs. And instead of 5, they need 10 packs of buns. So instead of 40 hot dogs, they're going to get 80 of each. Make sure your warm-up is complete and your workbook is filled in. Have a great rest of your day.